Okay. My name's Pat McGlynn. I'm the Flathead County Agriculture Extension Agent, and I'll be hosting tonight for Clane Jones. And for any producers that are online that don't know Clane, Clane has been our MSU fertility or soil fertility specialist for 16 years. And so we've had a long time to work together. It's been great. And this is the first class of a 7-week series. And we'll be listing some of the other classes at the end of this program. What I want to do is run over a few things about WebEx for some of you that aren't familiar with it. If you're having trouble hearing us, you can write it in the chat box and I will try to help you, but you can also call in for audio. So make sure your volume's turned up on your computer, be on that bar on the very bottom of your computer. And then also you can call in with this toll-free number that's on the screen right now. And if you can't find it, give me a chat in the chat box, and I'm going to talk about that in a minute, and I'll help you with that. Let's see. And let's see, to improve reception, if you could shut down all your other programs that you might have on your computer. I'm kind of laughing to myself because I'm thinking, yeah, I would have the news on right now. I mean, I feel like we're fiddling while Rome is burning, but it would be interesting to have something else going on, but it's going to slow down your wireless. And so you really want to have your camera off, and you want to have no other programs running in the background because you'll have better reception. Otherwise, things might freeze up for you. So you really don't want to have your email going and everything else at the same time. And just to let you know about the chat box, there's a chat box to the right-hand side. You'll see the word chat, and there's a little arrow there. And if you click on that, it's going to open up a little place that says, write your message here. I have to click that off myself. And you can either write, there's a little box there, and it says to everyone, and everyone will see your question. And it might be a great question that everybody else has. Or if you want it to just go to me because you're having trouble with your computer or you're having trouble with WebEx, you can also make it a private message to just Clane or just me, or put it in there for everyone to see. I'll be continually looking at the chat while Clane is teaching and presenting. And every so many slides, 10, 15 slides, Clane's going to stop anyway and ask for questions. But I will also be checking that chat. And if there's something that can't wait till that question, I'll interrupt Clane if he doesn't see it. Otherwise, I'll wait and I'll give him a whole list of questions, and we'll go through them to make sure that you've got all the information that you want before we get started. I think that's all we have right now. In case you have any problems, again, the chat, your volume, turn off your, there's a, right at the bottom of the screen, you see where it says stop video. So in case you have your camera on, we're going to turn, you'll want to turn that off. The other thing is everyone will be muted so we don't have background noise. And if there's a reason that we need to have you unmute, we can do that. So anyway, sit back and enjoy the show.
Okay, great, Pat. And Pat is going to be recording. So if you miss something, or let's say the audio or video fails, or you know somebody that wanted to see this, we will have this recorded. I will upload it to YouTube sometime in the next couple of weeks, and then we can send all the registrants a link to that. So again, my name's Clane Jones. Glad y'all could make it. I've missed traveling the state in the last 9 months since COVID hit. I've missed seeing people and seeing landscapes, and I'm just a little bit stuck, like probably some of you feel a little bit stuck. But I'm so thankful that we have the internet, that it's not 1918, and that we can deliver and still educate each other. So this is a 7-week series. Something I'd like you all to keep in mind is that we're going to have people on here who have essentially very little soils and fertilizer background. That's why they're taking the class. Others of you are extension agents, crop advisors, NRCS personnel with more experience. those of you with more, if today just starts seeming like a review to you, I won't have my feelings hurt if you log off. But just keep in mind, we're going to slowly build through these 7 weeks and go from basic topics to applied topics. If you have any questions after the presentation today, always feel free to give me a call or send me an email. So today I'm going to cover soil properties and how they affect plant nutrients, teach you how to read a soil test, discuss the limitations of soil properties that you can influence, talk about the 4 R's of fertilization, which means the right source, the right rate, right placement, and timing. And then, that's the main things I'm going to cover today. I did want to start with the concept of what's the difference between soil quality and soil health, even though that's not the main focus today. When you read a soil test report, you really start understanding the soil quality that you have of maybe your garden or your farm. These two terms are used interchangeably, but I want to be a little clear, and I discuss them a little bit differently. So soil quality I think of as properties that are difficult to change. So that would be things like soil texture and what's called cation exchange capacity, which I'll discuss later. Soil health, which has become, I think, a little bit more the hip term, I think of as more dynamic properties that can be changed with management. Some of these are measured in a lab, some are a little more qualitative. So these include things like aggregation, how well does soil stick together, microbe activity, the general term of tilth, nutrient availability, water holding capacity, and compaction. One question would be, well, where does soil organic matter and pH belong? I view that they belong on both lists because they're a quality of your soil, somewhat difficult to change, but over time, with management, you do have the ability to change both. So what does an average soil composition look like? We think of a soil as solid, but it's really only about half solid. About half is mineral, 2% is organic matter. That can vary. Air represents about a quarter, and water represents about a quarter. Certainly in Montana, it can represent quite a bit less. Soil properties that affect soil nutrients and plant health include things like texture and pH, cation exchange capacity, and organic matter, which is really small in volume, meaning here like 2%, maybe in a really rich garden, 10%, or maybe in a wetland, it might be 15%. But it controls probably greater than 90% of the function of soils. So what should you look for if you get your soil tested? What should you look for on a soil test report? The first things that probably most of you will look at is the nutrient content, and that's probably why a lot of you would have your soil tested. How much fertilizer do I need to add? How many do I need to add amendments to my pasture or my garden or my farm? But I'm going to encourage you to look at some of the other things first because they so affect plant health and nutrient availability. So for example, soil organic matter, you have less than 1%, you really need to work on increasing that, either by growing, say, a cover crop or adding a manure amendment. If you have greater than 3%, the nice thing is that you can claim a nitrogen credit. What that means is you can back off on how much nitrogen you need because that organic matter is going to supply some nitrogen. Another thing you should really look at first is soil pH. So if you have a soil pH that's less than 5, you likely have some aluminum toxicity. Al stands for aluminum. This is a growing problem in Montana, especially on dryland cropping systems. If you have less than pH 6, you're probably going to have some poor establishment and maybe some issues with legume nodulation. Legumes and the bacteria that grow on the roots of legumes that make these nice nodules and take nitrogen out of the air, they do not like it when you have pHs less than about 6. Montana, we generally don't have low pH. We often have high pH, and that's our bigger problem. So if you have a soil with pH greater than 8.3, nutrients can be tied up, and you likely have high levels of sodium, which can be bad for your soil. Another factor to look at on a soil test is soluble salts. What you want to look for there is you don't want to have soluble salts more than about 4. Funny units, but generally they'll have a number there, and usually in Montana they're less than 1. But if you have greater than 4, you have a salty soil. What that does is essentially wilts your plant. It's almost like the plant doesn't have enough water. It's fighting to take water out of that salt. And then two things that are actually rarely tested on a soil test report. You actually have to make an extra effort to ask for these, are soil texture and cation exchange capacity. But they tell you a lot about hold water and hold nutrients. So I recommend getting them at least once or twice. So thinking about soil texture, if we have a clay particle, which is invisible at this scale, a silt particle and a sand particle, essentially at these ratios from large to barely able to be seen to invisible, what happens as we go from clay to sand is the water and nutrient holding capacity goes down. That probably makes sense. Sands can't hold water as well. They also don't have as much surface area, so they can't hold nutrients as well. Sand can have large pore spaces, low surface area, low ability to hold water or hold nutrients. Clays can have a lot of small pore spaces, but they also can have some large cracks, like shown over here. They have a large surface area and a high ability to hold water and nutrients. I think an ideal soil is a loam to a clay loam, which means approximately equal parts sand, silt, and clay. So for those of you that got the email that said, hey, if you can dig soil right now, if it's not frozen and you want to do this, let's find out what your soil texture is. And for those of you that don't have soil in front of you, this is something you can do later. Go to this recording, you can go to our webpage and actually do the mason jar test. So this is soil for my home. It was so easy to dig. Usually in January, soil for my home is not so easy to dig. The white in there, I've already added my dishwasher detergent. And the reason for the dishwasher detergent, it's called a dispersant. And it breaks up those aggregates where clays are held together. If you don't break those up, those aggregates fall out of the solution and basically get recorded as sand. Now I'm going to add water. Put on the lid. And give it a good shake. So add water to almost full, add about a teaspoon of dishwasher soap. Again, that breaks up. Now I'm going to shake it and I'm going to let it all settle. At about 1 minute after you do that shake, the sand will have already fallen out. So you're already partway done this test. You have one of the 3 constituents, clay, silt, and sand. You can see in this picture here that this soil is actually 45% sand. And sand often has a different color to it. So you can see my sand has already begun to settle out, and it's a lot lighter in color than my silt and my clay above that. So we're going to take a look at that later in the talk. The perfect way to measure your silt is to wait for 6 hours. That's just based on how fast it takes for silt to settle out of water. But most of us are going to be asleep in 6 hours. A lot of labs actually use 2 hours. So I would say 2 hours from now, set an alarm and mark with a Sharpie where that sand layer was and where that silt layer is. And then you can calculate clay by difference because you know roughly where the top of the soil was, or you just wait 24 hours and you can mark the top of the clay. So then what do you do? Well, then you can go to a soil textural triangle that has clay on one side, silt on another, and sand on the other. Using that jar from the previous photo, what I found was that this soil, or that soil in the mason jar, was basically a loam. So it fell right in here. So I went up on the sand, I went across on the clay, and I came down on the silt, and it just came out to be roughly a loam. If you haven't collected soil for this jar test, but you find some soil at some point, you can also feel it. Clay will feel really sticky when wet. Sand will feel coarse and gritty. Silt will feel silky smooth when wet. And you can get a rough idea of your soil texture. So why is texture so important? Well, it affects a lot of different things: infiltration, water holding capacity, aeration, and cation exchange capacity. So as you can probably envision, sand drains really well, doesn't hold water very well, is very well aerated, and has low ability to hold cations or nutrients because it doesn't have a lot of surface area. Clay, on the other hand, is essentially opposite. Doesn't drain well, has excellent water holding capacity, doesn't really aerate well, and has a high ability to hold cations and nutrients. And then silt is essentially in between those two. So cation exchange capacity, you can think of this as the parking spaces for nutrients in the soil. Cations, the definition of a cation is a positively charged nutrient like potassium or ammonium or zinc. Soils are generally negatively charged. Both soil organic matter and clays are negatively charged. So these cations, indicated by yellow and green circles, will get attracted to the soil. This is actually a really good thing. You might think, well, if a nutrient sticks to a soil, a plant can't get it. Why is that a good thing? Well, it's actually just an attraction. It's a weak attraction, like static electricity, holding my hair up or sticking dust to my hair or to a balloon. So it can come off easily. These nutrients can come off easily, but they also have less of a chance of leaching because they're attracted to those soils. What you want to look for on your soil test report is the CC, and you would like it to be of about 15 or so. A large surface area soil generally will have a larger cation exchange capacity. We give a couple examples here. So for example, a clay soil will have a cation exchange capacity of about 40. It will have a surface area, believe it or not, of about a football field, 1 tablespoon, a football field. That is huge. A loamy sand, on the other hand, 1 tablespoon might only have the surface area of a table. So if you can picture that surface area of a football field, that's why it can hold nutrients so well. What else might high CC soils also hold on to? They can also hold on to herbicides. So that might be a bad thing in that it might keep herbicides from being effective, soil applied herbicides. It might also keep those herbicides from breaking down. So to use kind of lingo in the ag world, the rotation interval between when a herbicide is applied and when you can grow a sensitive crop, say lentils, might have to be increased if you have a soil with a high cation exchange capacity. CC of mineral soil is hard to change, but it can slowly change soil organic matter. So SOM is the abbreviation for soil organic matter. What does it do for the soil? As it decomposes, it releases nutrients bound in that organic matter. It also can hold water. So this is a graph that shows as soil organic matter in percent by weight increases, the available water holding capacity also increases regardless of the soil texture. So a sand with more soil organic matter holds more water, silty clay loam holds more water, and a silt loam holds more water. So that might seem like an easy way for your soil to hold more water, but it's not always so easy to increase soil organic matter. Any gardeners out there, it's pretty easy because you can add, say, manure. Farmers who are farming 7,000 acres, not so easy. One nice thing about soil organic matter is that some fairly small changes can produce some fairly large benefits to your soil. So this is some work that shows the effect of soil organic matter on this horizontal axis on water-stable aggregate. So water-stable aggregate is a chunk of clays held together that are good for soil, because if you have a lot of these chunks, it's very easy for water to move down, it's very easy for nutrients to move, and it's easy for air to move down. So you want those to be stable because you don't want a raindrop to come and destroy it. So water-stable aggregate, good. Soil organic matter, notice that relatively small changes in soil organic matter, especially down in this range, 1 to 2%, can have very large increases in water-stable aggregate. So even though soil organic matter doesn't represent much of the soil, it can have a big impact on soil health, especially in this range, which coincidentally is the range that a lot of Montana soils are in, 1.8 to about 2.5. So aggregate stability helps with, as I mentioned, infiltration, root growth, and also reduced erosion. So here's a little quiz question for you. Think to yourself, you don't have to answer this, how long you think it might take to increase soil organic matter from, say, 1.4 to 1.5% if you do some practice, like maybe growing cover crops or growing perennial alfalfa that should presumably increase soil organic matter. Do you think that's going to take 2 years, 10 years, 20 years, or 50 years? And we kind of know, we at least know from one long-term study in Bozeman. MSU did this study, and what they found was that a conservation reserve program, or CRP, a mix of alfalfa and grass, increased soil organic matter from 1.4% to 1.5%. It took 10 years in the top foot. So here's a graph of all of the different rotations in that study. So this is work done by my colleagues Rick Engel and Perry Miller. What they studied was the effects of tilled fallow wheat, no-till fallow wheat, continuous wheat, wheat on wheat, pea grain followed by wheat, pea forage followed by wheat, a cover crop of pea followed by wheat, and then CRP. And they tracked soil organic matter in tons per acre after 10 years. Right here was the initial soil organic matter in 2002. Notice that both fallow systems lost soil organic matter. So summer fallow means nothing is being grown, there's no photosynthesis. So soil organic matter is only decomposing. It's not being built. The systems that did build soil organic matter include wheat on wheat, pea grain followed by wheat, and the CRP systems. The pea forage system lost a little soil organic matter. You're harvesting a lot of that forage. It's going away. And the cover crop wheat system, a little surprising to me, only maintained soil organic matter. So the answer to this question is it takes about 10 years to increase soil organic matter a little bit. Haying likely loses soil organic matter because you're harvesting so much of that biomass off. Are there any questions so far on anything? Again, that was probably a review for some of you, and probably for some it was brand new.
No questions in the chat, Clayne.
Okay. All right, I'll keep monitoring the chat. Do ask questions. That's why I'm here, to get your questions answered. So I am getting question from Pat. So with the SOM slide, does a perennial system most likely build soil organic matter over the long term? So yeah, so perennial systems probably have the best chance of increasing soil organic matter, and that's because they are photosynthesizing and growing from, say, maybe late March all the way into early November in a warm fall. Whereas all of these annual systems have long periods of time where they're not. So that perennial system's taking carbon out of the air, putting it into roots. The annual systems are putting a lot of their carbon above ground, not into roots. And then a lot of that is getting harvested. So yeah, perennial systems should have the best chance of building soil organic matter over the long term. We didn't find big differences here, but we only looked in the top foot. We are looking deeper this year, but I would expect perennial systems to build soil organic matter. Any other questions? All right. So other things to look on, or some of the things I mentioned just kind of as a review to look for on the soil test would be, again, soil organic matter, soluble salts, and soil texture and cation exchange capacity. Moving on to pH. So pH is a big deal because it affects two things. It affects nutrient availability, and if it's too low, it can actually affect toxicity. What this figure is attempting to do is show the effect of soil pH going from 4 up to 10 on nutrient availability. A wider bar indicates more nutrient availability, a narrow bar indicates less availability. One issue that's been happening in Montana that we just discovered about 5 years ago is a number of our agricultural systems are becoming more acidic. So we are finding pHs in this upper 4 to kind of upper 5 range. In that range, as you can picture from these nutrient bars, nitrogen's less available, phosphorus, potassium, calcium, magnesium, all less available. Some of the metals like copper are less available. But other metals like iron, zinc, manganese, and aluminum are higher. And it's this aluminum that ends up really killing crops. This is still, even though it's a growing problem in Montana, it's still the minority, meaning we have more pHs in Montana that are up around upper 7s and 8s. Now here you can see we also have nutrient availability issues, low N, low P for phosphorus, low potassium. Generally, we don't see calcium or magnesium issues at high pH, but we might see metal deficiencies. Iron and zinc, manganese, copper are all low at high pH. Where you'd really like to be is somewhere between about 6 and maybe 7.5. This range, most nutrients are quite available. Question I got from Kim is, how does weather impact soils? So weather, because it's been happening for tens of thousands of years, a lot of precipitation can leach out nutrients. Low precipitation, drier areas in Montana, say Bridger to Havre areas, those areas generally will have higher pH. Those nutrients will be there, but because of that dryness, sometimes it's hard for the plant to take up those nutrients. So certainly temperature, warm temperatures, a lot of precipitation tend to leach nutrients. Cool and dry tend to store nutrients. So we have decent nutrient availability in Montana, except for things like phosphorus, which tends to be pretty low in our high pH soils. So what does historical pH look like in Montana? This was a graph or a map put together by the old soil scientist at NRCS, meaning the retired soil scientist. What it shows is a map of Montana with the legend over here. So you can probably start eyeballing where you live and figure out the rough pH in your valleys. Notice that most of the state is green. So if we go to green over here, that means most of the state is 6.5 to 7.3. But there's quite a few areas that are yellow and even orange, okay, especially in eastern Montana. So those are quite high pHs, 7.3 up to 8.4. And then there's pockets of low pH on the west side. Most of these are associated with mountains, but not all of them. How about more recently? So this is a map showing counties. Any county that has a circle or a star in it is one that we've identified as having pHs less than 5.5. That's a big deal because less than 5.5 legumes do not fix much nitrogen, meaning they don't produce nodules and take nitrogen out of basically the soil air. So we didn't know about really any counties back in about 2010. And now we know about 24 counties in Montana that have low pH, and I'm guessing there's even more. We just haven't located them. The scariest one to me is that 40% of 20 random locations in Choteau County have pHs less than about 5.5. So that's a big chunk of a large county with a lot of acreage. The soil pH distribution in north central Montana, this is data gathered from AgVi's labs, which I would guess analyze probably half the soils that are tested in Montana. What it shows, as I mentioned, is that, the majority of soils in Montana are in this, 7 to about 8.2 range. That's where the bulk of the soils are. But look at this kind of growing tail here, where there's quite a few soils below that, not nearly as much as in this high area, but these are these low pH areas where essentially nothing grows. So that's a big concern, and I'll cover this more later. So if you think you might have a low pH issue, I highly recommend sampling in the top 3 inches. Standard for agricultural soils and for garden soils is 6 inches. But going from 0 to 3 to 3 to 6, we can find big increases. And so that sampling that top 6 can really do what I call like mask the issue. And that's really exemplified here in 2 studies done in North Dakota, where they sampled 0 to 3 inches, 0 to 6 inches, and 0 to 12 inches in 2 different studies. What they found was in the 0 to 6 and 0 to 12 inch depths, they had pHs above 6, so not really the place where my alarm bells go off. But at 0 to 3, they actually had 5.8, so this might start having issues. In this 19-year study, they actually had pHs of 5.4 in the top 3 inches. If they had instead, say, a farmer or a gardener sampled the top 12 inches, 0 to 12, they wouldn't recognize that they really had probably a fairly major problem, probably some toxicity and some nutrient availability. Some people consider tilling to correct this problem because pHs are higher down low. If you are considering tilling, I would recommend getting that next 3-inch depth. If it's no higher, then tilling's really not going to help. Also, you want to avoid compositing samples from different slope areas. We generally find pretty different pHs on ridge tops than down low or on slopes. If you mix all that into a bucket and send that sample in and you had pH 8 up on the ridge, 5 down, say in a low spot, you're going to mask the issue and you might get a test report back that says 6.8. You won't know you have that pH 5 area. So that's why I would recommend sampling in different slope areas. So is this a real issue or is it just us looking for more research dollars? Well, this is a drone imagery of a safflower field up in Big Sandy that really shows that there are areas in Montana where nothing is growing because of this low pH. Safflower is one of the more sensitive crops, but this is not what any farmer wants to see on his or her field. So there are crop losses from low pH. Below about 5.2, you can experience aluminum toxicity. Below 6, your nodules won't grow very well on your legumes like lentil, pea, alfalfa. Less than 6, there can be increases in certain diseases. Also, herbicide efficacy or effectiveness and its persistence can also change. Different crops, tolerance to low pH varies. So alfalfa has a fairly high, minimum pH. You don't want to be below about 5.7 with alfalfa. Barley's a little more tolerant. Pea can handle maybe 5.5, but not much below. And then wheat is probably the most tolerant of these 4 crops. And I will cover more about this in February 10th session. Any questions so far? Okay, I'm going to move on to soil nutrients. So whether you're in Western Montana and maybe you have a small pasture, or you're a gardener, or you're a large acreage producer, I would say for sustainable, healthy production, you really want your inputs to about equal your output. So you want to be adding about what you're removing. To minimize how much inputs you need, you want to minimize your losses. So those would include erosion, runoff, leaching losses, also any losses to the atmosphere. And I do see I got a question. Is this limited to no-till systems? And I think what he's referring to in this question is this the low pH issue, and it's not. So the biggest cause of acidification is nitrogen rates that exceed what a plant needs. And so we can see low pH in both no-till and till systems. No-till, we see it a little bit first because without tilling that soil and bringing up higher pH from down low, we're concentrating that low pH generally about 2 or 3 inches down in the soil near where fertilizers apply. And so we do see it a little quicker in no-till, but I have seen it in till systems as well. So let's think about inputs. Inputs would include manure, fertilizer, and fixation by legumes, naturally occurring organic matter in the soil. Losses would include harvest, erosion, runoff, leaching, and what's called volatilization or escape to the atmosphere. In many ag systems, some outputs exceed inputs. For example, potassium would be a great example. There's a lot of potassium in clay soils. So economically, it doesn't make sense to pour on a lot of potassium fertilizer. But at some point, you might start mining the soil too much, and then you have to add some back. So there's 14 mineral nutrients that have been found to be essential for the growth of most plants. And those are broken into the 6 macronutrients and the 8 micronutrients. There's 3 other nutrients that plants need that aren't called minerals. So mineral nutrients just mean these come from the soil. Carbon, hydrogen, and oxygen are also needed for plants. In fact, those are the biggest 3 components of plants, representing about 95% of plant biomass, but those come from the atmosphere or from water. We don't have a lot of control over those, so these are more the ones we focus on. The ones that are bolded and red are ones that somebody, including myself, has observed deficiencies of in Montana. And we will cover micronutrients on January 27th. So I just want to walk through the nitrogen and phosphorus cycle. We see these are generally the nutrients that are most limiting in Montana. So the nitrogen cycle, we can think of it as, say, starting with organic material. Organic matter can get mineralized, which just means decomposed, to ammonium. Ammonium can either stick to soils or undergo a process called nitrification. Gets converted over to this NO3 minus, which is just the chemical term for nitrate. And then that nitrate can be taken up by plants. There's also this process I mentioned called nitrogen fixation that occurs on legume roots. And I did get a question, how would a wheat safflower wheat rotation, so wheat, safflower, wheat, be for organic matter? I think it would be pretty good. Safflower is pretty deep rooted. Wheat leaves a fair amount of residue. As you saw from that previous graph on soil organic matter, basically any rotation that excludes fallow is likely going to be good for soil organic matter. On this graph, I'm going to show losses in red. So harvest would be a way that nutrients leave the field. Ammonia can volatilize, like ammonia cleaning solution. You've probably smelled it volatilizing. There's also losses called leaching, where nitrate can leach out of the root zone and presumably to groundwater. And then it can also, nitrogen can run off. Finally, nitrogen can get converted back to where it came from, which is nitrogen gas. 80% of the air we breathe is nitrogen gas. So those are all the losses that you want to minimize if possible, so you don't have to add additional nitrogen and so that your crops or vegetables do well. We're going to cover it in more detail the next 2 weeks. Phosphorus might look similar to nitrogen. It has some similarities in that organic matter is in the phosphorus cycle, but a lot of phosphorus is tied up in minerals. So my teeth are made of calcium phosphate. If you think how insoluble teeth and bones are, phosphorus is very insoluble. Something that makes this phosphorus cycle easier to understand, though, is that there's no gaseous phase of phosphorus. So fortunately, unlike nitrogen, we can't lose phosphorus to the atmosphere. Phosphorus sticks really strongly, so notice even though I have leaching shown here, it's not a major way that phosphorus is going to be lost. Another question I got was, why does adding excess nitrogen to the soil lower soil pH? So great question and pretty timely too. So low pH is caused by high amounts of hydrogen ions, H+. When ammonium, which is the major form of nitrogen fertilizer, gets nitrified over to nitrate, you have to picture, well, what happens to all these hydrogens? These hydrogens go into solution. And so it's that process called nitrification that lowers the pH. So good question. So one question that people have with phosphorus is, if I can control my pH, hard to do on a farm scale, fairly easy to do, say, in a greenhouse or in potting soil or maybe even a raised bed, where would I want my phosphorus or my pH level to be? So this is a graph showing the effect of pH on phosphorus availability. Phosphorus availability is pretty low at low pH, comes up to maybe around 6.5 at peaks, and it starts going down because of precipitation at high pH with calcium. At low pH, it also goes down because of a process called sorption, which is where phosphorus sticks to the outside of soil particles. So if you could, for phosphorus availability, you'd like the pH to be somewhere around 6.5. So a thought question for you is, at what pH levels would you likely need to fertilize with more phosphorus? Below 6, above 7, or below 6 and above 7? And the answer would probably be below 6 in here and above 7. In between those, you probably don't have to fertilize quite as much. Any other questions before I do my last part? Okay, so on to soil testing and recommendations. So some questions to ask before you add a fertilizer or decide not to add a fertilizer or maybe add a soil amendment would be, which elements do I need? Do I need nitrogen? Do I need zinc? The 4R stewardship indicates that we should try to apply amendments and fertilizers at the right rate, using the right source, the right timing of that, the right placement, and then I like to add the right rotation, meaning if you add legumes into a rotation, that can decrease the amount of nitrogen that you need. And so a legume, in a way, is a source of nitrogen. And then another question to ask is, will I get a return, either financially if you're a farmer, environmentally if that's your goal, or in the form of maybe good vegetable yields if you're a garden. So soil testing is really necessary to know how much fertilizer you need to add. If you don't know what's in your soil, you really can't guesstimate how much to add. It can also help you identify nutrient deficiencies, can increase your yield, decrease environmental risks. When to do it? I would recommend, especially on large acreage fields, to do it if you can, or if your crop advisor can, in early spring. And that's because early spring is the best estimate of nutrient availability for the growing season. We have a couple of what we call Mont guides that have more instructions on soil sampling. And I did get another question, are there cover crops that optimally increase soil pH? I wish there was. We've had 2 different studies where we've looked at pHs after growing cover crops, and we have not seen giant benefits of cover crops. The biggest advantage cover crops have is when they have legumes in them, because then you don't have to fertilize as much, and then the pH doesn't drop as much. So let's say compared to continuous wheat, where you're putting on a lot of nitrogen every year, cover crop and wheat would not drop the pH as much. But as far as a cover crop that raises the pH, we haven't discovered that yet. There's different ways to get soil test data. One is to send soil to an analytical lab. Another is to analyze your own with what's called home kits. But we have found home kits not to be ideal, and other people have actually studied how good are home test kits, and they don't seem to do very good compared to laboratory results. So how to soil test and what to do before you send the sample to the lab. We have 2 soil scoops. One's called Getting a Good Sample, and one's called Once You Have the Sample Checklist. So this checklist is handy to write down everything on here, because odds are the lab is eventually going to ask you for most of this information. They're going to want to know what you want analyzed. They're going to want to know the prior crop, because that affects their recommendation. They're going to want to know the intended crop. And if you farm, they're going to want to know the yield goal. So what does an example soil test report look like? Typically, you'll write down what your desired crop is, often your prior crop. Nutrients like nitrate will often be given in either ppm, which is concentration, or pounds per acre. Our fertilizer guidelines, meaning MSU fertilizer guidelines, require that the lab give it to you in pounds per acre, or you need to convert. I often recommend for agricultural crops that soil be sampled to either 2 feet or to 3 feet, meaning 36 inches. So soil test report will have levels of nitrogen in pounds per acre for each depth, and then they often add those up because the roots can access all of those. Another thing that's often on soil test reports will be phosphorus levels. These can come with different what's called extractants or methods to analyze that phosphorus. One method is called the Bray test. Another is Olsen. I recommend Olsen. And then potassium is generally analyzed as well. Down here at the bottom is I have ranges for each of these showing ideal levels. So you can compare your soil test report to these ideal levels. If we look here, the Olsen phosphorus levels are below our ideal Olsen phosphorus levels, and potassium has a good range somewhere between 250 and 500. So this one fits nice in there. This one's probably a little deficient in potassium. So sometimes soil test reports don't give you a number, or they focus on more of a qualitative number. And so they might say low, medium, high, or sufficient or deficient. The numbers really allow you to determine fertilizer rates, though. And soil test kits almost always give you a rating rather than a number. Sometimes labs do provide a recommendation. Make sure that your recommendation is based on your desired crop and its yield goal. And you probably should compare and make sure that the lab that you're using is using Montana guidelines. We've done decades of soil fertility trials here, and so we know how much nutrients our soils and all our crops need. If you use a testing lab in North Carolina, they might have different recommendations that don't work well for us. If you don't like hard copies and you like using a computer, you can go to Southern Ag Research Center's Soil Fertility Guideline Calculator. So they use our guidelines that are hard copy, and they put them, my colleague Kent McVeigh has put them into a nice user form where you type in your phosphorus, your potassium, your organic matter, your nitrate levels, what your yield goal is, what your last year crop and your new crop is, and it tells you how much nitrogen, phosphorus, and potassium you should consider using. Keep in mind, MSU guidelines are based on Olsen phosphorus. Not all labs do Olsen phosphorus. Bray can work below pH 7.3. Olsen works well above pH 6. There's a test called the Malick 3 test. It works pretty well over a broad range. If you do get a soil test back and it only has the Malick phosphorus test on it, you can convert to get over to Olsen phosphorus. So this is what our MSU fertilizer guidelines look like, specifically for winter wheat, where we have Olsen phosphorus soil test level that you had measured in your soil test report up here. And then how much fertilizer do you need for those particular phosphorus test levels? So hopefully this makes sense. As the amount of phosphorus in the soil goes up, the amount of phosphorus that you need for, in this case, to grow winter wheat goes down. So for example, for this particular example with 4 parts per million, you'd come to here, you'd go down here, your winter wheat would need 50 pounds of P2O5 per acre. So look at your soil test, figure out your soil pH, what phosphorus test type was used, what your phosphorus soil test level is, and then what your recommendation is based on this table, or a lot of times labs will give you a recommendation. So just to sum up this evening on this first day of the Soil Fertility webinar series, understanding soil properties really helps guide proper fertilization. Do you have a really coarse soil that nutrients are going to leach out of with low organic matter? Or do you have a clay soil, maybe with a lot of organic matter? Soil tests, that online calculator, and our publications are important tools to help you calculate fertilizer rates and also maximize your plant health while protecting the environment. And the right rate, source, placement, timing, and rotation leads to optimal fertilizer use and plant health. finally, you need to observe and adjust to your specific conditions. So Montana fertilizer guidelines, whether they're for agriculture or for a garden, are trying to give you the best recommendations for a really large state. So the best thing that you can do is to really observe, like, are you seeing nutrient deficiencies? Is your crop or your plants a little bit yellow? Does your soil test consistently indicate that you have too much of a nutrient or too little of a nutrient? Then you have to adjust for your weather and your soil. So now what I'd like you to do, for those of you who did the soil test, the texture test, is look to see if you have soil that's starting to settle. And what I'm starting to see is a line here where silt is below that line. Again, sand is this lighter colored material at the bottom. I can see, you probably can't see on the camera, it's a lot coarser, but my silt level looks like to about here, and probably in another few hours it might have settled a little bit, and then I'll look again tomorrow in about 20 hours from now and see how much clay has accumulated. For additional resources on this topic of soil testing and how to read a soil test report and basic soil fertility, you can go to my website, landresources.montana.edu/soil fertility, where you'll find all these documents that can help you with soil testing. And with that, I wanted to thank you and see if there's any questions. I did get a question: how much leached nitrogen can be recovered by a deep tap-rooted crop like safflower? And interestingly, next week I'm going to cover that. I don't think I'll exactly answer that question, but the deep-rooted aspect of safflower can pull up a lot of nitrogen before it, say, leaves a root zone or enters groundwater, and certainly better than a more shallow-rooted crop, say like barley. So any questions on anything that I covered today? Someone said, can we please get the link for the online fertility calculator? So yeah, so there's two ways we could do that, Pat. One would be, I can just leave this up here while I field other questions. This will also be on the recording. And I know Catherine's on right now, and she can just jot down to send this link and maybe any others to registrants, maybe along with the reminder for next week's session. Other questions? When doing soil samples, we've been doing GPS points, so we can measure same point every year. Do you recommend this? Definitely. So something very frustrating as a soil fertility guy is that soil is extremely variable. So for example, out here at the post farm this year, I measured pH 5.2. I walked 30 meters and I measured pH 7.2. So when you're trying to decide, should you lime that field? It's really hard to know when it can be that highly variable. And so, yeah, for all of our research, we have GPS points so we can go back to the same point. For those who don't, the risk always is that you might think, for example, that you're building up phosphorus and maybe you're just sampling in a different area that has higher phosphorus each year. So I think it's an excellent idea. How and where to send soil samples? So that's a good question too. There's about 10, I'd say about 10 regional laboratories, 3 in Montana. The Midwest has quite a few. North Dakota, there's a lab called Midwest Labs. In Nebraska, AgVise. What I would do is go to Interpretation of Soil Test Reports for Agriculture. We have a very similar sounding one that's for gardeners. And again, you can find both of these on my webpage. And the back page of those two documents has a list of laboratories. And so you can find that on my web page. The how. So the how for large acreage agriculture, I'd always recommend using Crop Advisor. They have hydraulic probes that can go to 3 feet. You generally can't auger or push to 3 feet. So for large acreage, I would call up a fertilizer dealer and do that. For pasture, for like small acreage pasture or home gardener, you can use anything like a tulip bulb planter to go down through soil. Generally, I recommend maybe up to 10 samples for an area. You mix that in a bucket, put that in a bag, and then you can send off. But I would really pick up one of these documents on interpreting soil test reports for agriculture or for home gardeners, because they have a few more tips in there along with the list of laboratories. And I can see in the chat box that Catherine just provided a document, a link to a document on my website that you can copy and paste into a browser. And the other thing that I'd like you to keep in mind before you start disappearing for the evening is Catherine's also going to be supplying a link for you to give feedback. So this is the first of this series. I teach this way on campus, but that's a little different. So we'd like your feedback on what worked tonight and what didn't work this evening. And so we have a little 3-question survey that I think Catherine's going to hook you up with soon. Other questions? Okay, so I see the link. I see the link there. If you're out of questions, if you're going to be signing off, please click on that and fill that out, and then hopefully we will make the remaining ones better suited, especially focus on kind of this remote aspect and what could make that better. And grazing animals impact soil pH. I would say relatively little. Manure generally is high pH. You are what you eat. Grasses tend to have pHs in the 7 to 8 range, and so manure comes out about in that range. And so the animal itself probably doesn't have a really big effect, but I have seen right here in Gallatin County where manure spread on an acidic field just greened that field right up. The pH jumped from 4.5 to upper 5s, and the wheat took off and it turned nice and green. So manure can have a positive impact on pH. Grazing animals, I would guess, as a whole, not a huge impact. All right, well, as we wind down and some of you fill out that survey, the last question I see there is, what time of year is best to spread manure? I would say probably in the spring. The risk with fall is there can be quite a bit of nutrients like nitrate and sulfate that can leach out if you put it on in the fall and you end up with a wet fall. So I think probably in the spring, if you're growing annual crops, maybe if you can spread it thinly a little before seeding, or put it on your crop when it's not very, very tall. Probably could work to put it on after harvest. That would give some time for it to break down, but again, I'd worry about just losing some of those nutrients over winter. So I think early to mid-spring. Pat, is there anything that you'd like to add, or maybe any questions that somebody sent directly to you that I can answer?
No, I don't have any more questions sent to me, but thank you. It was great.
Okay. What I put on this last slide is future sessions, just to get you thinking of what's happening the next couple of weeks. Nitrogen fundamentals. So I'll go into more detail than just that nitrogen cycle. talk a lot about rate, source, timing, and placement. And then on the 20th, get a little more into nitrogen for specific crops like cereals or pulse crops. So those are going to be the next 2 weeks. All right, well, thanks everyone. If your soil
there's one more.
Okay, if your soils already have a high pH, then can manure raise the pH level even more? I would say no. So by high, again, I see manure in that 7 to 8 range. So if you have a high pH around 8, it's probably going to have relatively little effect, maybe even bring it down a little bit. So I don't think it'll raise the pH level even more. And I'm happy to stay on for a few more minutes. The questions keep coming, and I'd rather get your questions answered. So I'm gonna sit tight here until I know people are out of questions. But for those of you logging off, again, great questions. Thanks for participating. Thanks for your feedback. Have a good week, and I will see you next Wednesday. All right, I'd say you can go ahead and turn off the recording, Pat, if you haven't.